Chapter 7 Transport Layer. In this chapter video, we will talk about the purpose of the transport layer, the characteristics of the TCP and UDP protocols, including port numbers, explain TCP session establishment and termination processes, explain the transmission and acknowledgments of data units, and explain the differences between TCP and UDP protocols. The transport layer has several functions and responsibilities, which are establishing a temporary communication session between two applications and delivering data between them, being linked between the application layer and the lower layers that are responsible for the network transmission, providing a method of delivering data across the network in a way that ensures the data can be properly put back together. The transport layer provides the segmentation of data and the controls necessary to reassemble these segments into various communication streams. Some of the responsibilities of transport layer protocols are tracking the individual communication between applications on the source and destination hosts, segmenting data for manageability and reassembling segmented data into streams of application data at the destination, identifying the proper application for each communication stream, tracking the conversations. Each particular set of data flowing between a source application and a destination application is known as a conversation. Multiple applications can communicate across the network simultaneously. It is the responsibility of the transport layer to maintain and track these multiple conversations. Segmentation. Most networks have a limitation on the amount of data that can be included in a single packet. Transport layer protocols have services that segment the application data into blocks of data that are an appropriate size. This service includes the encapsulation required on each piece of data, a header, used for reassembly, is added to each block of data. This header is used to track the data stream. At the destination, the transport layer must be able to reconstruct the pieces of data into a complete data stream that is useful to the application layer. Identifying the application. To pass data streams to the proper applications, the transport layer must identify the target application. To accomplish this, the transport layer assigns each application an identifier. This identifier is called a port number. Each software process that needs to access the network is assigned a port number unique in that host. Conversation multiplexing. Sending some types of data across a network as one complete communication stream could use all of the available bandwidth and prevent other communications from occurring at the same time. Without segmentation, only one application would be able to receive data. To identify each segment of data, the transport layer adds to the segment a header containing binary data. This header contains fields of bits. It is the values in these fields that enable different transport layer protocols to perform different functions in managing data communication. Transport layer reliability. The transport layer is also responsible for managing reliability requirements of a conversation. Different applications have different transport reliability requirements. IP does not specify how the delivery or transportation of packets takes place. Transport protocols specify how to transfer messages between hosts. TCP/IP provides two transport layer protocols, Transmission Control Protocol, TCP, and the User Datagram Protocol, UDP. IP uses these transport protocols to enable hosts to communicate and transfer data. TCP is considered a reliable, full-featured transport layer protocol, which ensures that all of the data arrives at the destination. UDP is a very simple transport layer protocol that does not provide for any reliability. TCP. TCP includes processes to ensure reliable delivery between applications through the use of acknowledged delivery. TCP transport is analogous to sending packages that are tracked from source to destination. With TCP, the three basic operations of reliability are tracking transmitted data segments, acknowledging received data, retransmitting any unacknowledged data. TCP breaks up a message into small pieces known as segments. The segments are numbered in sequence and passed to IP process for assembly into packets. TCP keeps track of the number of segments that have been sent to a specific host from a specific application. If the sender does not receive an acknowledgement with a certain period of time, it assumes that the segments were lost and retransmits them. TCP is responsible for reassembling the message segments and passing them to the application. UDP. UDP provides just the basic functions for delivering data segments between the appropriate applications with very little overhead and data checking. With UDP, there are no transport layer processes that inform the sender if successful delivery has occurred. The right transport layer protocol for the right application. For some applications, segments must arrive in a very specific sequence to be processed successfully. With other applications, all data must be fully received before any of it is considered useful. Any missing data could cause a corrupt communication that is either incomplete or unreadable. Therefore, these applications are designed to use TCP. In other cases, an application can tolerate some data loss during transmission over the network, but delays in transmission are unacceptable. UDP is the better choice for these applications. Therefore, TCP provides connection-oriented conversations by establishing sessions, negotiates and establishes a permanent connection or session between source and destination devices prior to forwarding any traffic. The session is terminated only after the communication is completed. Reliable delivery. Reliability means ensuring that each piece of data that the source sends arrives at the destination. Order data reconstruction. By numbering and sequencing the segments, it can ensure that they are reassembled into the proper order. Flow control. It can prevent the loss of segments on the network and avoid the need of retransmission. While UDP features are connectionless, unreliable delivery. There are no processes within UDP to have the sender retransmit any data that is lost or is corrupted. No order data reconstruction. UDP does not provide any mechanism for reassembling the data in its original sequence. The data is simply delivered to the application in the order that it arrives. No flow control. UDP does not control the amount of data transmitted by the source to avoid overwhelming the destination device. With UDP, there is no mechanism for automatic retransmission of dropped data. Role of TCP. Each TCP segment has 20 bytes of overhead in the header encapsulating the application layer data. This is considerably more than a UDP segment, which only has 8 bytes of overhead. Extra overhead includes sequence number, used for data reassembly purposes. Acknowledgement number, indicates the data that has been received. Header length, known as data offset, indicates the length of the TCP segment header. Reserved, this field is reserved for the future. Control bits, includes bit codes or flags that indicate the purpose and function of the TCP segment. Window size, indicates the number of segments that can be accepted at one time. Checksum, used for error checking of the segment header and data. Urgent, indicates if data is urgent. Role of UDP. UDP is a stateless protocol, meaning neither the client nor the server is obligated to keep track of the state of the communication session. It is also considered a best effort transport protocol, as well as a lightweight transport protocol. The pieces of communication in UDP are called datagrams. In the case of applications, data must flow quickly, and if reliability is required when using UDP, it must be handled by the application. Port addressing. In the header of each segment, there is a source and destination port. When a message is delivered using TCP or UDP, the protocols and services requested are identified by the port number. Every message that a host sends contains both a source and a destination port. A client places a destination port number in the segment to tell the destination server what service is being requested. The source port number is randomly generated by the sending device to identify a conversation between two devices. This allows multiple conversations to occur at the same time. Therefore, the combination of the source and destination IP addresses and the source and destination port numbers is known as a socket. The socket is used to identify the server and service being requested by the client. A socket pair consisting of the source and destination IP addresses and port numbers is also unique and identifies the specific conversation between the two hosts. With the creation of sockets, communication endpoints are known so that data can move from an application on one host to an application on another. There are different types of port numbers, and these are well-known ports. These numbers are reserved for services and applications. Registered ports. These port numbers are assigned to user processes or applications. Dynamic or private ports, also known as ephemeral ports. These are usually assigned dynamically to client applications when the client initiates a connection to a service. Unexplained TCP connections can pose a major security threat because they can indicate that something or someone is connected to the local host. Additionally, unnecessary TCP connections can consume valuable system resources. TCP and UDP handle segmentation differently. Information may arrive in a different order than it was transmitted because different packets may take different paths through the network. An application that uses UDP must tolerate the fact that data may not arrive in the order in which it was sent. UDP does not reassemble segments in order as TCP protocol. TCP server processes. Application processes run on servers. A single server may run multiple application processes at the same time. These processes wait until a client initiates communication with a request for information or other services. Each application process running on the server is configured to use a port number, either by default or manually by a system administrator. An active server application assigned to a specific port is considered to be open, which means that the transport layer accepts and processes segments addressed to that port. Any incoming client request addressed to the correct socket is accepted and the data is passed to the server application. One way to improve security on a server is to restrict server access to only those ports associated with the services and applications that should be accessible by authorized requesters. After the communication between the two hosts is completed, the sessions are closed and the connection is terminated. The connection and session mechanisms enable TCP's reliability function. TCP is a full duplex protocol, where each connection represents two one-way communication streams or sessions. To establish the connection, the hosts established that the destination device is present on the network. Verify that the destination device has an active service and is accepting requests on the destination port number that the initiating client intends to use for the session. Inform the destination device that the source client intends to establish a communication session on that port number. As we can see, there are 6 1-bit fields that contain control information used to manage the TCP processes. Those fields are URG, Urgent Pointer Field Significant, ACK, Acknowledgement Field Significant, PSH, Push Function, RST, Reset the connection, SYN, Synchronized sequence numbers, FIN, No more data from sender. TCP three-way handshake. Step 1. The initiating client requests a client-to-server communication session with the server. TCP client begins by sending a segment with the synchronized sequence number, SYN, control flag set, indicating an initial value in the sequence number field in the header. Remember, the ISN in the header of each segment is increased by 1 for each byte of data sent from the client to the server as the data conversation continues. The SYN control flag is set and the relative sequence number is at 0. Step 2. The server acknowledges the client-to-server communication session and requests a server-to-client communication session. The TCP server must acknowledge the receipt of the SYN segment from the client to establish the session from the client to the server. The server sends a segment back to the client with the acknowledgement ACK flag set indicating that the acknowledgement number is significant. Remember, with this flag, the client recognizes this as an acknowledgement that the server received the SYN from the TCP client. The value of the acknowledgement number field is equal to the ISN plus 1. This establishes a session. The server must initiate the response to the client. To start the session, the server uses the SYN flag in the same way that the client did. Step 3. The initiating client acknowledges the server-to-client communication session. TCP client responds with a segment containing an ACK in response to the TCP SYN sent by the server. The value in the acknowledgement number field contains one more than the ISN received from the server. After both sessions are established between client and server, all additional segments exchanged in this communication will have the ACK flag set. Finish control flag must be set in the segment header. To end each one-way TCP session, a two-way handshake is used, consisting of a finish segment and an ACK segment. Step 1. When the client has no more data to send, it sends a segment with the FIN flag set. Step 2. The server sends an ACK to acknowledge the receipt of the FIN to terminate the session from the client to server. Step 3. The server sends an FIN to the client to terminate the server-to-client session. Step 4. The client responds with an ACK to acknowledge the FIN from the server. Reliability. During session setup, an initial sequence number ISN is set. It represents the starting value for the bytes for this session that is being transmitted. The sequence number is incremented by the number of bytes that have been transmitted. This tracking enables each segment to be uniquely identified and acknowledged. Missing segments can be identified. Expectational acknowledgement. Sequence and acknowledgement numbers are used together to confirm receipt of the bytes of data. The sequence number indicates the relative number of bytes that have been transmitted in this session, including the bytes in the current segment. TCP uses the acknowledgement number to indicate the next byte that the receiver expects to receive. Flow control. The TCP header includes a 16-bit field called the window size, the number of bytes that the destination device is able to accept and process at one time. The initial window size is agreed upon, and the source device must limit the amount of data segments sent based on the window size. Only after the source device receives an acknowledgement that the data segments have been received can it continue sending more data. Dynamic window sizes. When network resources are constrained, TCP can reduce the window size to require that received segments are acknowledged more frequently. After a period of transmission with no data losses or constrained resources, the receiver begins to increase the window field, which reduces the overhead on the network. This happens because fewer acknowledgements must be sent. The window size continues to increase until there is data loss, which causes the window size to decrease. In conclusion, TCP is best suited for applications that need reliable transport and can tolerate some delay. TCP handles all tasks associated with segmenting the data stream into segments, reliability, flow control, and reordering of segments. It frees the application from having to manage any of this. There are three types of applications that are best suited for UDP. Applications that can tolerate some data loss but require little or no delay. Applications with simple request and reply transactions. And unidirectional communications where reliability is not required or can be handled by the application. Thank you for watching.